Hey guys, welcome to Conceptual Geometry, Lesson 4.9, Dilations. First, what is a dilation? A dilation is simply an enlargement, or you can call it reduction. This is one of the transformations that you guys probably use every single day and you don't even realize it. For example, before we even get to dilating this triangle, I want to show you what a dilation is. You do this probably on your phones dozens of times every day. A pinch zoom is an example of a dilation. So how do I sketch a dilation? I want to sketch the image of triangle ABC under a dilation of scale factor 2. So that little number there tells us how many times bigger our new shape becomes. And P is the center of dilation. So here's how it works. What I want you to do first, you just do this freehand, is sketch in a segment from P to B. Then I want you to replicate that segment on the other side of B. And again, we're just going to approximate it about the same length. And this segment, or this point I should say, is twice the distance from point P as B is. So that's where my scale factor of 2 comes from. 1, 2. So B prime would be out here. Now we'll do the same thing with A. It doesn't really matter what order you do this, and just go to the other side about the same distance. And there's A prime. C will be a little bit more challenging because it's further away to do freehand. Then I want to go about the same distance. Actually, I kind of go down there. And there's C prime. So now what we can do is just sketch in that triangle. And this triangle, A prime, B prime, C prime, is twice the size of the original one. So this side right here, AB, is twice the length, or sorry, A prime, B prime, is twice the length of AB. So we said a dilation is an enlargement or reduction. So we can actually reduce these shapes as well with a dilation. In this case here, you see the scale factor is 1/2. So D for dilation, scale factor 1/2, which means our resulting shape is half the size of the original. So how do we do that? Well, like we did up above, we sketch in lightly a dashed line, a segment from A to R. And now I need my distance to be half of that. So half of that distance is approximately here. That would be your R prime. Then we'll do the same thing from A to P. And estimate approximately halfway right there is P prime. And now do the same thing from A to Q. It's a little bit further away. And let's estimate halfway there. That would be Q prime. And then the last thing we do is just sketch in that triangle. Now you notice this new triangle formed is half the size of the original. So this side, P prime, R prime, should be half the length of side PR. Okay, let's try this on a coordinate plane, or grid, if you will. Sketch the image of the figure below under a dilation of scale factor 2, with the origin as the center of dilation. So here's my center of dilation. You can kind of think of it with a grid, it's much easier. Sketch this line in from the origin to A, and then I want to double that. So it ends up going right here. Now I'm not going to sketch all of these in because I don't want to clutter it up too much. So that would be A prime. Now I'll do the same thing to B. And if this is my origin, what I like to do is sort of count how many blocks I have to go to get to B. So it looks like 3 diagonals, and I go 3 diagonals. So B prime would be right there. C is here, so it looks like I go over 2 up 1, over 2 up 1, ends up right there. And then do the same thing for D. So it looks like over 4 up 1, over 4 up 1. D prime goes right there. And then lastly, sketch in those segments. All right, so that is a dilation of scale factor 2. Now let's take a look at these coordinates. A prime, where did that go? That was 2, 4. B prime, 6, 6. C prime, 4, 2. And D prime, 8, 2. Now check this out. The rule for dilations is really simple. I start at 1, 2. I ended at 2, 4. Oh, I just doubled them, right? 1 times 2 is 2. 2 times 2 is 4. So basically I took those coordinates, I multiplied by 2. Well, the question is, where does that 2 come from? That's your scale factor. So whatever this scale factor is, that's what we multiply all of our coordinates by. Notice all of those we just multiplied by 2. So that brings us to our rule. The rule for a dilation of scale factor k of the point xy is k times x, k times y. So our first example here says rewrite each of the following using a rule for transformations. Basically, they want us to write down the transformation rule, and it says xy went to 6 times x, 6 times y. So that is simply a dilation of scale factor 6 because I multiplied both coordinates by 6. In my next one, xy goes to negative x, negative y. So what did we multiply by? We multiplied by negative 1. So in this case, my scale factor is negative 1. These next two are not dilations. All right, these next two are either reflections or rotations. So what I'm noticing here is that going from the first point to the second, I negated y. So you can look in your study guide, when you negate the y, that is a reflection in the x-axis. And the last one here, what I'm noticing is I just switched the coordinates, yx, and that is a reflection in the line y equals x. Again, those two are review from earlier on in the unit. Example 5, use the rule xy, 2, 3x, 3y. So basically here it's telling us multiply both coordinates by 3. Pretty straightforward, doesn't take that long. If I multiply both of those by 3, what do I get? Negative 12 comma 15. Multiply both of those times 3. That gives me negative 3, negative 24. And multiply both of those by 3. Just be careful. Remember, 0 times anything is 0. So that's going to be 0, 9. Okay, question number 6. Similar, except they give us a dilation instead of a rule. Here it says a dilation of scale factor 1/2. So remember, when we multiply by 1/2, that's the same thing as dividing by 2. We like to use multiplication when it comes to dilations. So if you divide both of those by 2 or multiply by 1/2, you get 1/3. Multiply both of those by 1/2. You can use a decimal if you want or keep it a fraction. 3.5 comma negative 4. And here, multiply both of those by 1/2. You get negative 4.5 comma negative 5.5. All right, in question 7, they want you to come up with the dilation. So here, they're giving us the beginning and the end, and they want you to determine what you multiplied by. Because whatever you multiplied by would be the scale factor of that dilation. Okay, so here, and you just have to pick either the x or the y. It's going to be the same rule for both. Negative 2 multiplied by what is negative 6? That's times 3. So this is a dilation of scale factor 3. Let's go in order here. So B, the zeros aren't going to tell me anything, but 9 went to 3. So you have to go left to right, or the object to the image. So what do you multiply 9 by to get 3? Well, it's less than 1, right? Because the number gets smaller. It's 1/3. Or you can ask yourself, what did I divide by? Well, I had to divide by 3. So division by 3 is the same as multiplying by 1/3. So this is a dilation of scale factor 1/3. Okay, C. 1 times what is 4? Well, 1 times 4. So this is a dilation of scale factor 4. Letter D. 4 times what is 1? Well, it got smaller, so it's got to be less than 1, and that's going to be 1/4. So this is a dilation of scale factor 1/4. E, 2 times what is 4? That's times 2, obviously, so it's a dilation of scale factor 2. And the last one on this page, -6 times what is -1? Well, that's times 1/6. So this is a dilation of scale factor 1/6. Okay, our last example, and this one's kind of tough. Now, if you notice, it gives you a grid here. I am not going to use the grid for this example. I want you guys to use your study guide. We are going to apply the rules. This is probably the most difficult question we do in the entire unit. It gives us the coordinates of the endpoints of a segment. E is 0, 2, N is 1, 4. And then they want you to determine, is the image the same of E double prime, N double prime, if you reflect in the origin, then dilate by a factor of 2. So I have to work out that whole problem here to see what I get. Then I start over. But this time, I dilate by a scale factor of 2 first, then reflect in the origin. So it's kind of like two separate problems. There's a lot of work to show for this. Okay, so let's start it. We are going to write down our original coordinates. E is 0, 2, N is 1, 4. Here's the notation I'd like you to use. You can just use one arrow here to represent the transformation. What we are doing first is reflecting the origin. Now remember, your rule for reflecting the origin is to negate both, -x, -y. So what I'm going to have next is an intermediate segment of coordinates I get by negating these two. Okay, so 0, if you negate that, it stays 0. 2 negated is -2. Then I negate 1, and I negate 4. So I get E prime, N prime. So I've done this part. So now I take these coordinates, and I dilate by a scale factor of 2. Well, remember what that just tells me to do. That just tells me to multiply both of those by 2. So this rule will be basically 2 times x and 2 times y. Okay, so let's draw another arrow. And above that, I'll write dilation scale factor 2. And I'll get my end result. E double prime, N double prime. And just multiply everything by 2. Okay, so that's 0, -4, and -2, -8. Now I'm done with that step. What I do now down here is I start over. All right, I take E, 0, 2, and N, 1, 4. But now what I'm going to do first is dilate by a factor of 2. So I'm going to take these coordinates and multiply them by 2. Dilation scale factor 2. So that gives me E prime is 0, 4. N prime is 2, 8. Okay, now I take these coordinates and reflect them in the origin. Well, remember, your rule for reflecting the origin is to negate both. So I write down here reflection in the origin. E double prime, let's negate both, 0, -4. N double prime, negate both, -2, -8. So the question says, are they the same? So now what you have to do is you have to compare your end result. Yes. The answer, I'll tell you right now, is not always going to be yes. It just depends on the transformations. But in this case, a reflection in the origin and a dilation of scale factor 2, if you change the order, you get the same result. Okay, guys, that concludes day 9. You have all the information you need now to complete the homework worksheet 4.9. Please reach out to me if you have any questions. Thanks for watching.